Saxon's Trig, Lesson 50, beginning on page 342, is about trigonometric equations. Very little is new here because what they're giving you in the first example is sine of theta equals 1 over root 2. Now this you're going to instinctively know, yeah, I need to graph it. Okay, I'm looking for a degree answer. Okay, that feels pretty simple. But it clarifies, given, and they have to clarify this, and I'll show you why, that your answers are between 0 degrees, it can equal 0 degrees, and your theta, matching from here, must be less than but not equal to 360 degrees. Okay, so if they do not give me this clarification, and I get in the habit of ignoring it and jumping instinctively to my graph, but you want to at least stop and look to make sure that you're getting answers where you want answers to be. If they give it to me this way, and then over here, instead of in degrees, they put it in radians, they want their answer in radians, not in degrees. Oh, well, that's a helpful thing to know. It also throws out certain answers. It just keeps me where they want me to be. All right, so let's go back and let's talk about which quadrant or quadrants I need to be graphing in. So this goes back to our all students take calculus. All three, sine, cosine, and tangent, are positive in quadrant 1. Only sine, students, is positive in quadrant 2. Tangent is positive in quadrant 3, and cosine is positive in quadrant 4. So automatically, I know I graph to all, and the other place where sine is positive is here. Now, the other reason I know I want to put it in two places is this is giving me a clue that I want to graph it everywhere I possibly can between 0 and 360. That's why this is super helpful. It tells me more than just being in quadrant 1. Okay, so my sine, opposite over hypotenuse. Opposite is 1, opposite is 1. Hypotenuse is root 2, hypotenuse is root 2. What does that look like? Oh, 1, 1, root 2. Yep, this one's negative 1, okay. And what degree is that? 45 degrees. Wonderful, so now I've labeled it in both places. So my theta from here will equal in quadrant 1, 45 degrees. Is that between 0 and 360? Yep. In quadrant 2, it's shy of the 180 by 45 degrees, so that gives me an answer of 135 because I always want to list the angle wherever it's falling starting from 0. And is that between the 0 and the 360? Yes. So now I know what my two answers are. All right, example 2. They now give us 2 plus root 3 secant of theta equals 0. And again, they tell me I've got to be between 0 and 360 degrees. Okay, so I know I'm needing to graph every single place where this could possibly work. Now, I don't have secant solved for. I've got a bunch of numbers with it. So before I can graph it, I need to isolate secant. So that means I've moved the 2 by minusing it. I've divided by the root 3 to remove it from in front. And now I have secant in a correct fraction format. It's negative, I can see that. And secant is the opposite of cosine, which was ca, so this should be hypotenuse over adjacent, all right? Which quadrants will I graph for the secant or cosine for the all students take calculus, because it's the opposite. It works exactly the same for those quadrants. So will it be in the all? Nope, because it's negative, it's not positive. And where's the other one? It cannot be. All students take calculus. It can't be here because that's where cosine is positive. So it's going to be in quadrants 2 and 3. So now my hypotenuse is, now it won't have the negative, so I know that negative is actually with this. So hypotenuse is 2. Adjacent is negative root 3, and that's good because you see it's in this quadrant, so I know it has to be negative. That's another big clue there. So this is the 1, this is negative 1. So what degree is opposite 1? 30 degrees, filled into both. So my theta over here will be not quite to the 180, it's a gap of 30, so that's 150 degrees. And now it's past the 180 by 30 more, So 210 degrees. Example 3. Solve 3 root 2 plus 3 cosecant theta equals 0. And again, it needs to be between 0 and 360. Okay, don't have cosecant alone, so just like before, I need to get it alone by moving the 3 root 2, making it negative 3 root 2, dividing by the 3, which was in front here, to remove it from the cosecant. And then this is going to simplify down to negative root 2. And because they need to be in fraction, I'm going to go ahead and write that one that I normally ignore. So cosecant is the opposite of sine, which is so we're going to have hypotenuse over opposite. So my hypotenuse is root 2, my opposite is negative 1. Which quadrants will I graph? So this is using based on sine. So it's negative, it cannot be in all, and it cannot be in students, but it will be in quadrants 3 and 4. So my hypotenuse is root 2, my opposites are negative 1. Yep, that matches with the quadrant, that's wonderful. So then, which gives me hypotenuse of root 2, the 1's, and this would be a negative 1. So 45 degrees. And now the theta will be, I wanted to say I can write this as negative 45, but that's not between 0 and 360, so no, I cannot. I need to go 180 plus 45 more, 225, I'll check that in a second. And then I need to go from 0 and be shy of 360 by 45 degrees, so that should be 315. There we are. 225, yes, and 315. Yes, okay. So now we have found the two answers in between. So you see how this is helpful for telling me. Now, I said I would tell you the other reason why they have to clarify this is if I just gave you sine of this, I could keep wrapping forever. 360 plus 45, 360 plus 135, 720 wraps twice plus 45, 720 plus 135. I could just keep listing answers ad nauseum if I didn't know that I only needed to give answers between 0 and 360. That's the other major reason why this is helpful. It limits me from just working nonstop.